So here we are, we're playing with diamonds again, and in case you haven't ever seen a big diamond, here's kind of a medium-sized big diamond. This is 120 millimeters across, one of my smaller big diamonds. I have them 150 and 200 millimeters across. And what these are, actually, they're full of carbon. They are just carbon, which is lighter than aluminum. This isn't particularly light, a kilo or so, maybe a little more, a kilo and a half, but not much more than that. For the size of it, that's not very much. It's pretty solid. But if I drill through here like this, and then drill it within this, I can take the end off here, somewhere in there, depending on the size of the thing I'm sticking it into, and then leave this like this, but take my milling machine and mill it out so that this whole thing is only, a few millimeters thick. And then it doesn't weigh anything. It's like a soap bubble. Okay? And I attach that to a rocket engine. Okay? Simple rocket engine. And the expanding cone, and it's going to expand inside there too, right? When I drill it out, I drill it with a pointy thing, right? And so I just drill it down to the point, and then I can make the hole any size I want. And then I'll take my milling machine and mill the rest out so that it has a hollow part all the way up to here, and then recompresses it a little bit. On a rocket motor that moves, it doesn't have to move much. I'm moving it a lot. I have to move like this, right? Boom, 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 boom. And so a joystick can control that movement. And I can burn hydroxyls in here, hydrogen and oxygen. They bind together, hydroxyls. Hydroxyls are the most reactive substance we know, because hydrogen is what moves all chemistry. It's that positive and negative. Right? The proton is positive and the electron is negative. The whole universe is made out of hydrogen atoms. Everything. Carbon is 6 hydrogen atoms squeezed together in a star. It wasn't squeezed together in the Earth. Those 6 carbon atoms are hydrogen atoms. They're all hydrogen atoms. Every one of them. There's no difference between an atom in a carbon atom and an atom in a uranium atom. It's just the number of them and how closely they're squeezed together that makes them do what they're going to do. Okay, so these are really squeezed together, and what we're doing today is making a little doohickey for a lamp, a lamp that burns hemp seed oil, and this is going to float in top. Let's see, so we can get the whole thing here. I can't actually see without looking around my camera. So I need to press that in a little bit more, but it doesn't hurt my diamond, even if I bang on it. This doesn't do anything, man. It's not even nearly as hard as a diamond, right? Um, I might be able to scratch my hammer. And little dog hairs, there's no charge at all. You can have them for free, and you get my stuff. They call me Mohair Sam. Things that are the same hardness can't scratch each other. Okay, this left some little scratches on there, but they're basically it didn't really scratch it, see? Yeah, a little bit right there. Because I pressed, right? I pressed. And that made it hard. Well, when I cut diamonds with a diamond thing, and like this. Oops, not that one. The other one, where'd it go? Okay. Whoops. There it is. Okay, so we've got diamond on here. And it goes round and round and round really, really fast. And that's why it can cut a diamond. It's just making little tiny, 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 tiny scratches on there. And it takes a long time when you do it with these. And I do it by hand usually. I'm using a little, Dremel-like tool. I'm not using. I have a nice lapidary and I made a diamond cutter, right, with table and all of that, and big 8-inch disc. And I switch the surface so that it's got different grits, and I bump them up to a polish like this. I didn't cut this. This came from Long Wen in Kowloon, China. Hold on.